With DoubtNet, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download DoubtNet app today.
Hello everyone, let us start with our question. In this question, what is given that there is a large heavy box which is sliding without friction down a smooth plane of inclination theta. Now from a point P on the ground of the box, a particle is projected inside the box. The initial speed of the particle with respect to the box is given as to be u, and the direction of the projection makes an angle alpha with the bottom as shown in the figure. We need to find the distance between the bottom of the box, along the bottom of the box, between the point of projection P and the Q where the particle lands. That means this distance we need to find, this horizontal distance along this plane. Now, first of all, what we can do, we should just remember one of the concept regarding the horizontal projectile motion. Now, if there is a horizontal projectile motion, a particle is projected with a velocity u at an angle of theta. So let's say this is our u, and it is projected at an angle of theta. So it would be following a projectile. So this would be the path. Okay, it would be falling here. Now this from here to here, this would be the range. And we can say that our range of the horizontal range, this value would be equals to u square sine 2 theta divided by g, where theta is what? Theta is the angle of projection from the this ground, or we can say that from the surface itself. What is g? G is the acceleration due to gravity. Now it would be perpendicular to the it is perpendicular to the horizontal surface. Okay, this is to be remembered, from which we are projecting it. Now in this case, okay, in this case, what we can see now, this box would be sliding downward in the horizontal direction. So it would be g sine of alpha. This would be the case. Okay, it would be sliding. Sorry, g sine of theta. Okay. Now this particle would also be sliding downward with the same acceleration g sine of theta. So we can say that they don't have any relative acceleration in the x direction. Okay. Now if we take the relative acceleration, so if we or we can say that we can make this stationary and give its acceleration to our point P. We first of all just draw our incline like this. This is our incline. Now the particle is projected like this. Okay, this is the projection of the particle. Let's say the velocity is u. Now for this particle, if we see, so it would be having a this component of acceleration parallel to the incline. Now this value would be equals to g sine of theta. Parallel component is g sine of theta. Now theta is the angle on the incline, and this perpendicular component is g cos of theta. Now this box is also sliding downward. Now if we bring this object to rest, then we need to give this a negative acceleration. So in this direction, that means we can say that it would be the pseudo acceleration due to the pseudo force. So it would be g sine of theta. Now here we can see that they don't have any relative acceleration in the x direction. This is our x horizontal, and this is our y. Okay, parallel and perpendicular to the incline. So they are having just our downward acceleration, or we can say that acceleration in the y direction, according to our y direction, which is minus g cos of theta. Now this situation and this situation would be same if we just tilt it by an angle of theta. Okay, so we can say that this for this case, our range would be equals to, or we can say that our distance pq, this would be equals to velocity square. Now here it is sine twice of angle which this velocity is making with the plane. Now in our case, what is the angle which is made by the velocity with the plane? It is our alpha. So we can say that it would be sine 2 alpha divided by g. Now g here is the perpendicular. It is perpendicular to from where we have projected the particle. This is the component. Now here, what is the perpendicular component of the acceleration? It is g cos of theta. So we can say that it would be g cos of theta. So this we can just directly infer with the with our comparison. So which is the correct option for this? So u square sine 2 alpha divided by g cos of theta. That means D would be the correct option for the part A. Now if we check for the second part, if the horizontal displacement of the particle as seen by the observer on the ground is 0. Okay, so for example, if there is an observer standing here and he don't see any horizontal displacement, he is not seeing, we need to find what is the speed of the box with respect to the ground. So let's say a box is moving with a velocity v, and this is having a velocity u. Okay, now he don't see the horizontal, so this horizontal is with respect to our this observer, not with respect to our incline. Okay, it is with respect to the ground frame, like this. Now if there is no horizontal displacement, that means the net velocity in the horizontal direction would be equals to 0. Now if you draw this this case for the second part, that means our part B, we just draw the incline. Let's say this is our inclined surface. Okay, this is our projection of the particle. This would be our u. So what would be the horizontal component of the velocity? If we say this part, this one, horizontal component of the velocity. So clearly we can see that this angle is our alpha. This angle is our theta. So total angle would be alpha plus theta. So it would be u cos of alpha plus theta. Now the box is sliding in this way, or we are just drawing the direction of the box velocity like this. Okay, this is the direction of the box velocity. Okay, now if we also take the component in this direction, we can say that horizontal to the plane. Okay, like this. If we take the horizontal part like this, so what is this? This is our v, velocity of the box. Now what would be this angle if we check for the vertically opposite? So this would be vertically opposite. So this component would be v cos of theta. Now to don't have any horizontal displacement, the net horizontal velocity should be 0. That means v cos of theta should be equals to u cos of alpha plus theta. So we can say that our v should be equals to u cos of alpha plus theta divided by cos of theta. So this would be the answer. So we have calculated both the cases, this part and this part. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.